those who don't know me, again, I'm Terry Busch. From DIA, we're going to talk about data. Some of you I know, some of you I don't. So whenever I give these talks, it's just like I'm either preaching to the choir or the unwashed masses. So some of you, this will be great, and some of you, this just, be very, very generic, and you've heard all of my anecdotes before. So going to get into the slides here. Boom. Oop. Uh-oh. Try that one. The big green one, right? It always happens to me. So maybe you could advance the slides up there. Or, okay, hand puppets. I'll talk. Clearly, we're having technical errors. We're used to this at DIA. First role of Chief Data Officer. It's a relatively new concept for those of you who've never heard of a Chief Data Officer before. About half of Fortune 500 companies today have a Chief Data Officer. Data has become such an important component of our information space that it was almost too much for a CIO to take on by themselves. Plus, data is changing the nature and driving our technologies in new ways before. So sort of getting the data right, the governance, the management, the life cycle, all that, is a big concept, and it's a big concept. So all the IC partners have a Chief Data Officer. I met with all of them before. Many of the services, many of the combatant commands are adding Chief Data Officers. And mostly we're focused right now on getting the policy and the strategy of data right? So it doesn't sound very sexy and exciting, but if you want to do all your AI stuff, you want to do all your machine learning stuff, and still nothing, the data has to be good, right? It has to be normalized, it has to be perfect, right? We also have to look at our data as not bound to our applications, not bound to anything else anymore. If we want to do this in a true and a perfect sense, it's agnostic, right? Our data is going to go to whatever application or capability you may have. So that's kind of the role of the Chief Data Officer. So that sort of sets the background. From a geospatial perspective, we have been in the geo business in DIA, well, for at least 30 years, probably longer if I really were to reach back in time. So the idea of understanding the components of geography and geospatial for us is very common. As all source folks, we are very set at using the data, bringing it in. We've used GIS forever. We've built visualization and mapping capabilities. But over the last 10 years or so ago, things began to evolve for us, especially around geospatial data. Data became, if you remember the DigiNet days, we tried to service enable our data to make it enterprise so everybody could use. Then we began to dimension our data, and eventually the magic happened, right? Where the data sort of broke free, and we could start to do big, new analytical, methodological things with our data. That's a great place to be. And if I had slides, you'd really see this working. So the data analysis fusion sort of began to happen. And then it began to grow and grow and grow. And lo and behold, let's say in the last 3 or 4 years, you see us really moving into machine learning space, computer vision space, and things like that, right? So really, really good for us. As we kind of look back on why we're successful at some of these things, and you know many of those programs already, it's that getting to big data was easy for us because it was geospatially organized, right? If it has a lat long, I don't need to build an ontology with it. It'll relate to all the other data that has a lat long. Very simple way to view things, and in this hall, everyone knows that. But in an all source world, fusing data is complex, right? We have to define it, we have to build relationships. It takes a lot of firepower to bring data together. In the geo world, yeah, not so much, right? And we have great technology, like we see here today, to do it. Any luck? Ugh. I said, all right. So I'm winging it here. All right. So the big question then became, is all big data geo, right? This is the fundamental question we kind of kick around. It's kinda is the story. It mostly is. Most of the data out there in the world has some locational attribute to it that we can use and leverage. There's statistics out there, by the way, they're totally made up. Anybody who tells you 80% of data is spatial in nature, that can't, like we looked, it can't be sourced. But a lot of it is, and that makes it life easier to do it. So the other thing is the new realm of data science. As I said, somebody one day, I wish I had a data science degree. It just wasn't invented when I was learning statistics. But if you look at the tools of data science, they're also the tools of geography, right? They're very much the same kind of concepts: supervised, unsupervised classification, Gaussian distributions. All the things we've done to dimension and use our data through the years are what we use in our data today, right? So there's this really brilliant tie-in between data science and geospatial, and we certainly have taken great advantage of that. The difficulty, though, is that's a small percentage of DIA's workforce. The rest of the workforce, not so much, right? So like all of you, we face the same data literacy challenges with big data and data science. We just don't have enough people who've had that kind of exposure that those of you coming out of the social sciences, physical sciences, computer sciences world have had to data, right? These concepts are a little bit foreign to them. And so we're embarking on new ways to figure out how to get them to leverage and pull and learn and use this data, but we really want it to be experiential for them, right? If I go give them a test data set and go, okay, we're gonna learn about standard deviations today, and we're gonna learn about variance, and we're gonna learn about kurtosis, they're not gonna be very interesting. If I teach them on the data set they use from a day-to-day experiential in their roles, hey, much better, right? So can we marry the technology here in this room with the data that's so prevalent today, right, and we're using? Next component of that is, of course, the volumes of data we're dealing with and the scaling of data. Now, we've been in the big data business for a while, right? So we're kind of used to this, right? And we're kind of used to these paradigmatic shifts when we went from, a few thousand to a few million, now to a few billion records, right? Like, we're surviving that, and we're relearning all the challenges of I/O and everything that we face with that. But we're struggling with is keeping the technology up into pace, because what we're finding, especially in the machine-assisted side of the house, is that we're rewriting the code every 12 weeks, right? New technologies come on board, we're finding new dimensions in the data, we're finding new ways to go. 12 weeks agile cycles or DevOps cycles are tough, right? We also don't have a framework in our security and accreditation space that's really mature enough to handle that kind of development right now. So that's something else we're challenged by. The other component of that is partnering with NGA and all of our other partners out there. I had some great slides on that. Trust me, it's really cool. I'll show you next year. No. One of the things that's happening in our private talks and things here is a lot more partnering, right? We realize today that we can't do things independently, right? Things happen too fast, too big. So what you're seeing right now is a lot of co-investment between NGA and DIA, not just on analysis and use cases, but on technology investment. And since NGA owns the geospatial roadmap, they're really our thought leaders in this space, right? Where they invest, we follow at DIA. And it's a really important concept to miss. We're better off if we work through NGA to do this. Hey, here we go. I swear I made slides. All right. Wow, that was hard. Can you put it in display mode? Oh, there he goes. All right, there's the history. There's the deluge. Talked about that. Getting big data right? So here's one thing I always say to folks, and if you're new to this, and again, all of you are somewhere along this, we've done this for a while. If anybody tells you that 70% of the job isn't data management and big data, leave the room, right? Behind the scenes, that's what it's all about for us. We are able to achieve what we're able to achieve because we're constantly handling errors, correcting errors. They come at us even on our most perfect, cleanest data set. It's happening all the time, and that is the most critical part of doing. If you want to do big data, machine learning, whatever you want to call it, the data has to be pure. That also challenges us with our legacy data. Our legacy data does not come forward as easily, And the way we can go at that, say through NLP technologies and things like that, you're not going to get the precision and recall, right, on that you would from a perfectly clean data set. Let's go here. So this is something somebody put together. There's the answer. You want to know what AI is? There it is, right? Perfectly clear, right? So I'm preparing data for a universe that covers all those thought areas, right? There's no real one way to boil it down, and we're going to pollute and dilute these definitions, and they'll be out the window by next year, right? Because everything crosses over with everything else. But at the bottom of this is the data's got to be right, and all this sort of ties in together. The good news is there's so much of this going on, right? We can learn and leverage from each other, and that's something within the IC it's kind of never spoken to, but the level of collaboration today compared to 10 years ago is unreal. Again, the geography is the underlying component. I just want to show a use case or two here within geography that we use, just watching the time, that sort of helps us. It's not just that everything's geo, it's how we can leverage and what we can get out of it. Great use case there, that was Haiti, what we learned from VGI data in 3 days, right? Had nothing, moved on. Let's go again. Here's the tools of data science. I challenge you, which one of those are not geo? Because I used just about every one of them when I was in grad school, right? So to me, data science is geo. All big data is spatial, kind of, sort of, but we act as if it is for most of what we do. When it's not spatial in nature, we have to find a way to dimension the data so that we can use it. Much more complicated to do. Okay, so here comes all the big data. One of the hardest challenges we've had is determining confidence in big data. It's really hard to do, and we like to throw dry erasers at each other and fight over this. But with NGA embedded with us, we were able to develop, as we merge our big data, series of confidence intervals so that we can get the human being out of the loop, right? It has to be automated. There's too much data for humans to be involved with, except the most critical things in the future. So how do I project to you, the user, my confidence in the data? I could do this by score, A, B, C, D, E, F. I could do it by percentage, rank order. It's all rank order, right? It's subjective. But what if I said, no, here's the provenance of my data, and here's how I got to confidence. So we're using a spider graph there to sort of do that. And what we're saying is, hey, we validated your data against multiple different confidences, right? Do we know about it already? Is it something that already exists? Can we confirm it in another source, say imagery? One of the biggest concepts is multiplicity. If Google and Esri and Amazon all say that's a thing, we have pretty high confidence that's a thing, right? They're usually not wrong, and then Maxar can come in and help us out if they are. Just trying to get some plugs in. So the key to this is to build your user confidence in the data. I will tell you that most of the big data we do around foundational intelligence is around 97 and 99% accurate. So we're off the charts. That's more accurate than our analyst-driven data, right? It just is. It outperforms what we can get with human error. So very, very important concept for this. And if you go into our foundational data set, you'll see this spider chart for every point that's in there, right? How do we know what we know about this? And if you want to, you can click and dimension it and see the entire provenance of that data. I have to get analytic confidence high for autonomy to occur, right? The analyst sooner or later has to give in and say, I accept this, right? I'm confident in it, right? I also have to break them sort of this habit of always having to visualize it in imagery, which is kind of a weird psychological obsession. Next slide. Another thing here again is conflation and convolution. Geography saves the day. I don't get just one record saying that's a thing. I get lots of records that are saying that's this thing, and they're all slightly different. So we've worked with NGA to develop very serious, very strong models to get the most highest geographic fidelity on anything that we're looking at, right? So at first, you can't just do geographic means sometimes. You can't just say, oh, I'll take the average of the lat longs, because all of a sudden, the hospital is in the middle of the river. So there's been a lot of good thought and a lot of good engineering work with NGA and DIA to get this part of the story right. And again, it's something outside of this conference I'm not briefing to anyone, but here it's an important part of the Geo big data story is Geo's driving confidence. Next slide. Data literacy, I'm looking for answers, right? Can we gamify data literacy, right? Can I put that experiential environment in your data, in your work set in an entertaining way to help build confidence and understanding of data and data science concepts? I don't know. You got a solution? I'll probably be over here right afterwards. You can talk to me about it. But I think it's a challenge for our community. The one thing about it we always say is you can't do big data without visualization. They go hand in hand, right? It's impossible. You can't just spit out the answer from your algorithm and not really visualize what that thing looks like. And that's not necessarily always a map, right? It could be lots of other ways to do it. But one of the things we always tell people is just look at it on a map. Nothing gives context to data more than putting it on a map and seeing it in real space, right? So the key for me to data literacy is teaching that in a spatial context because it is the best way to get comprehension about what you're looking at, right? If I'm looking at data blips on a histogram, or if I'm looking on a pie chart, or I'm looking on a map, which one of those gives me more context to the data? The map, right? So part of data literacy for me is also geospatial. Next slide. So this is our data-centric universe. It's where we're coming. All data is coming together. We have the legacy problem. We have huge, massive deluge of data problems. And I'm sort of seeing there's kind of these two people in the world, right? There's the people with a headache walking around like this saying, oh my God, this is hard, what are we going to do? And then there's these other people kind of running at that data, saying, yeehaw, you know? There's new narratives in this data to be had. That tends to be this audience, right? It tends to be the same data science, geo kind of people. So the back-end architecture we see in a lot of systems at DIA is building agnostic systems, building data that's separated from the data. We want our data to go to whatever environment you're working in. And building a better suite of tools and capabilities, that library, that algorithmic library, so that you can take what I know in my tradecraft and reuse it for yours. Next slide. That's it, okay. So, I completely botched that, but I will try and answer any questions that you may have. Probably not any after that debacle.
Terry, I don't think all that was your fault.
That's right.
We'll blame you anyway. If there are questions, bring them over to Lori, and we'll go from there. I do have one. So today, Project Maven is focused on full motion video and PED and so forth. One of the next projects that's coming up on Lieutenant General Shanahan's scope is DOMEX, right? So, document and media exploitation. What involvement do you have with the NMIC, DOMEX, and anything to do with Project Maven and Lieutenant General Shanahan?
Sure, do my best here. So, as we were doing this through the years, and we're sort of being the geodata guys, our focus was more ML, deep learning, CV technologies, right? Because they were closer associated with the kind of data we had. And we looked at NLP and text, right, that you would use to exploit documents and things. And we did some cool stuff, but sometimes there's no audience. And there was really no audience. I mean, we tried. So what we came back to was, well, somebody else is doing that, right? So the NMIC and the guys did terrific work. So here we have this state, right? They have these innovators out on the edge like Maven and NMIC and ATI5 down in Charlottesville and all those guys. And we're trying to find a way, right? Like, what's the library? Where's the centralization of all this good R&D that we're doing? So Maven has great concepts to build sort of that algorithmic library. DNI has similar concepts, and GA has very strong concepts there. I have strong concepts with where we're going with MIDB. You're about page 2, paragraph 3 in the story of where all this is heading. It's being figured out as we speak. The best news, as I said earlier, the level of collaboration on this is unprecedented. But if you want my stuff, you can have it. What we want is a future that's better built so that we're in a reuse state, right? Borrow and improve. with algorithmic-based analysis. That's sort of the next thing we're looking at. We have in the past experimented with that technology. There's great systems here that do it as well.
Are there any more out there? Any more questions? Okay, well, it's been our pleasure having Terry Busch here with us today.